Hi there. So here comes a short video in Python where I'll tell the difference and what objects are actually generators and how they behave in Python. So it should try to keep it short. So let's move here right to my screen. So I have here a terminal. I like to use Python. I could use the bare Python interpreter, but I have installed here the IPython. It can do a few more tricks than the bare Python interpreter. But just go for this one if you want. So I'm using the latest stable version, 3.13. So the question is, what happens with a function when it's a generator instead of a simple function? So let's just create a couple dummy functions, and it may help just so we don't keep thinking names, just name them in alphabetical order. So function A just returns some value. And then I have function B that is a generator. It yield 0. And function that yield 0 is not very useful, but the mere presence of the keyword yield inside the function bar just change it, change how it behaves. That's what we shall see. So just so that it's not that dummy, let's see. I have a function that well, let it be that dummy. Let me see. Yeah, then I can come later up on with another example. I could return the value here, so I return 1. So first things, if I ask for the types of these things, they both will show up as functions. What happens? There is an internal marker. Python already knows this is not an ordinary function. It's a generator function. How do we know that? In the inspect model, it just happens. Import inspect. And then inspect is generator function. I don't remember if it has underscores. So here, is generator function. And I can ask this of A, it's false. And I can ask this of B, and it's true. This doesn't make a difference in the way we call it. So just so we don't lose those of view, I just retype them here. So just keep them around. So just going up, just keeping it inside. Well, when I call A and put the result in a variable, you'll see what I get here is whatever we done. It's 0 already. But when I call B, what I get here is not 0, it's not this one. What I get here is a generator. It creates a new generator each time I call the generator function. So Python, we call the function, Python considers the yield keyword. It creates a new generator and stores the new generator as the return value. So you see you have a generator object. Now the generator object has not executed. It didn't run a single line inside B. So I'll retype B here so you can see that happening. B print starting generator. Then I use 0. And then I return 1. Oh, sorry. So we can have things on the screen. So when I call B, it doesn't print the starting generator. When I call next on the generator object, then it will run here. It will start running here and it will run until it first encounters yield. This yield expression will resolve to none, and it will return as value of the next function call. The result of this expression here. Here's just the number 0. So E equal next D. What does this run? E until that point, and I have now 0 inside E. Now, when I call next D again, D has a state. D knows that it's executing the function B, and it's at this point, this line of code. If I call next again, it will resume the execution here, will print this, and will hit the return. The way it returns values is by raising an exception. So we see like an error. The way not to see the error is to capturing the exception with the try except block. Otherwise, I won't have the return value of B. I don't think it's reachable if I don't capture the error anyway. So I just let it give us an error. I'll do it a second time so we can get to the return value. So I'll try to put the value of the next iteration of the generator D on the variable F. And I got a print. It resumes the execution from here. It prints generator function. And then it raises a stop iteration error. And the stop iteration error has the value 1. This is the value. So the return value is actually the value in the exception. When we use a for loop, it does that automatically. So when it reaches the end of the generator, it just goes on and does nothing with this value. If you want this value, you have to use a try except. So you capture the exception. So I have to create it again. D equal P. Next. So throw away the first 0. And then if I want to capture the value, I have to try next D again. And then if it raises stop iteration, I have to assign it a variable. And this variable in except blocks is erased by Python automatically once we are out of the except blocks. Since I want to fiddle around with it interactively and introspect it, I'll assign it to another name. Python does remove this variable as it has a lot of references to whatever was running when the exception happened, and this would create memory leaks if it wasn't erased. So this is another story. Thinking right now, stop. I have the exception object itself, and if I'm not wrong, it does have a value. So that's it. So this is how you capture returned values in generator functions, and they are separated from the yielded values. And then let us focus on how generator functions actually work. They resume so it may not be clear from here. It resumes execution. So this is a bit useless. Let me go back to here. So instead of this, let's do a generator which yields quadratic values. So it receives a parameter n and goes for E in range. And so it's a quadratic generator right now. I yield E squared. Once it's over, okay. We already checked these, so I'll just not return anything, so it doesn't distract us. Okay, so now I can use this generator anywhere I use a sequence. You normally use generators with for loops. So if I want to use this in a for loop, it's all right for me. It automatically does the next thing, picks the value yielded and attributes it to J. So this gives me the sequence of the 4 first square numbers, print J. And when it's over, it will raise that stop iteration exception. It just stop the for command, and we use it. Let's see. And the thing is, more confusing. I can have more than one of these in parallel. So each time I call B, it creates a new generator. So if I call D0 equal B5 and D1 equal B5 again, or just use another number here so you can see it's different. So these are different instances of generators, and the template used to create this instance is the B. Okay, so these are the different objects. So it has the send, the next method, and I can now walk on either of these, and it won't affect the other ones. So once I call next on D0, it will run here, calculate the first value, and return me it. And it is independent of this one. So next 0, I'll call it just twice in a row here. So I'll walk 3 steps on the generator 30. I just threw away the first 2 return values for the quadratic of 0, quadratic of 1, and I have the square of 2 here. And if I do it the same with D1, it's back at 0. It's now the 1, the 2, and now I pass it ahead of the other. I have the square of 3, square of 4, square of 5, and the next one will finish it as I told it to go to 6. So to stop at next to it, change to 6 here, and so. And now I can have the square root of 3, square root of 4. Oh, sorry, I just went for D1, generator finished. And for D0, I should have another 4. And now it finishes it. And that's it. I'll keep this video short. We can keep chatting about the generators and stuff on another session. All right. So stop it.